Behind these walls, precision decides global power.
This is not a weapons factory. This is where precision is engineered. Microns matter. Errors are not tolerated. Every component is tested against extreme conditions.
Nothing moves forward.
That is for it.
Nothing moves forward without absolute confirmation.
When precision reaches this level, it shapes more than machines. This is how extreme precision shapes global power.
This facility does not build weapons directly, but the ultra-precise components that define global strategic balance. Every component begins as tightly controlled raw material, and the transporter rolls toward the material preparation zone. Engineered for stability under extreme conditions, these ultra-dense alloys are now moving to the cutting station for precision work. Precision begins at the first cut.
Even microscopic deviations are rejected.
The enclosed machining prevents vibration and contamination, which allows the milling process to begin. The CNC mill moves with slow, deliberate precision, achieving micron-level accuracy as the tool follows the complex contours.
Despite the increasing levels of automation, human oversight remains critical.
Structural symmetry is essential for high-performance components. This guides our inspection process, ensuring every part meets our rigorous standards.
Here, verification always takes precedence over speed. We ensure every single point is meticulously measured for ultimate precision.
Surface integrity reduces stress concentration. Visual inspection complements digital checks. Temperature cycling tests material stability. Monitoring expansion and contraction closely. As the component reaches peak temperature, we initiate the cooling sequence to ensure thermal resilience. The gradual cooling prevents microfractures, and the rack rolls toward another inspection zone.
We maintain a stable waveform until an acoustic anomaly, like this spike here, indicates a subsurface flaw.
Every approval is logged, and the component advances on a conveyor.
Contamination control is paramount in this environment. As we transition into fine machining, the air curtain ensures no particulates enter the cell.
Concentric accuracy is paramount. As the tool slowly retracts, we can observe the flawless internal finish achieved by the precision lathe.
Simulation confirms physical results, leading toward final finishing.
The controlled spray application ensures an even coat, providing superior corrosion resistance essential for aerospace specifications.
Uniform protection ensures long-term reliability.
We are now beginning the controlled oscillations. These mechanical pulses simulate real-world stress, ensuring the component's stability under motion.
Scan complete. All indicators green. Phase 1 success confirmed. The component is secured within the shock-isolated transport vessel. Utilizing multi-factor authentication, the container is the sealed container proceeds to the next phase. Our compartmentalized production protocols guarantee the integrity of the asset at all times. No component advances without consensus.
As we move deeper into the facility, the next phase involves the intricate automated assembly of the primary components. Accountability is paramount here. Every seal is checked against the manifest, ensuring the integrity of the shipment before it proceeds.
Attention Transport 7. Raw processing is complete. Proceed for final assembly.
Container secured on pad 4.
Copy that.
Locks engaged. Proceed with unloading sequence.
Today, we move forward together into a new era of integration. Phase 1 is complete.
Readiness confirmed. We are now initiating the next stage of the manufacturing process ahead of schedule.
Precision at this level defines everything that follows. Inside the nuclear warhead component factory, extreme precision shapes global power. Phase 2 focuses on transforming precision parts into functional subassemblies. Isolation is essential before secondary machining.
These channels regulate internal balance, and the tool retracts as the component advances.
Approved subassemblies now move towards system-level preparation. Responses remain within tolerance, and the platform powers down. As we move this assembly, we ensure that cleanliness increases as complexity rises.
Preparation is the most critical step. Here in the staging zone, our engineers meticulously prepare every
Only with perfect optical alignment can we proceed with the joining process.
These custom-molded covers ensure complete protection of sensitive aerospace components during transit and storage.
Automated guided vehicles are the backbone of our internal logistics, ensuring precise and timely delivery of critical components.
Precise alignment requires controlled, deliberate movement. Ensure all reference points are perfectly matched before engaging the clamps.
Assembling these components requires precision. The structural unity of the final product depends on the calibrated torque applied at this stage.
The gauge checks the tolerance before the digital scan. The system analysis confirms a perfect, seamless integration. The assembly is now secure. We begin the settling time sequence, allowing the stress equalization to complete.
Once stabilization is complete, the assembly is moved to the final Phase 2 inspection area. This ensures the highest quality before integration.
The Phase 2 assembly is now secured. All clamps are engaged, ensuring an airtight seal until extraction.
In a fully automated system, precision is paramount. Every movement is controlled, ensuring seamless progression.
Stable thermal response confirms material consistency, and the system transitions into cooling. The gradual normalization process is essential to protect the internal geometry and structural integrity of the components.
Now that the thermal systems are secure, we're transitioning to the acoustic validation. This is a key part of our environmental response testing protocol.
Acoustic behavior is evaluated to ensure internal stability during low-level vibration tests. Reviewing the data confirms that the acoustic response remains within acceptable thresholds. With acoustic validation complete, the assembly is cleared for the final certification steps.
This review confirms that traceability and comprehensive documentation are critical elements of accountability.
We need to ensure these verification points are fully addressed before sign-off.
Approval requires consensus across engineering and inspection teams.
This laser-etched code ensures permanent traceability, linking critical data to the part for its entire lifespan.
Identity verification is crucial, preventing any unauthorized substitution of the data.
The shielding covers lock firmly into place, safeguarding these sensitive interfaces during transport and ensuring flawless delivery.
The assembly is secured, calibrated, and ready for immediate dispatch. We understand that containment security is essential for controlled movement. That's why we utilize the latest scanning technology. Dispatch remains internal and controlled. Ensure the twist locks are fully engaged before transport. Proper securing is critical for safe handling.
Processing sequence finalized. The platform is now transferring the subject to the primary staging area.
In an operation this complex, precision is everything. It is the very foundation of our responsibility.
With the transport secured, the facility returns to full containment protocols. All threats neutralized.
The logs confirm completion, but we know that success today demands vigilance tomorrow. There is no room for complacency.